What is 1D kinematics? Before we start, let's go over some key notes that are important to understand when dealing with kinematics. The first one is that 1D kinematics describes motion in one dimension. So what that means is if we have some plane like this, we can describe the motion of a point moving forwards, backwards, forwards, backwards again, same as if the plane was vertical. We could describe its motion going up, down, any motion in this plane. It's important to note that the coordinates do matter. So because we're dealing with vector quantities here, such as velocity, acceleration, displacement, so we always have to set up a coordinate system, such as this one here, where we could say right is positive, up is positive, making down negative and left negative. We have to remember that these formulas that we're going to be using are only valid when we're dealing with constant or uniformly accelerated motion. What that means is that the acceleration is not changing in that time. So an example would be if an object is accelerating at 2 meters per second squared, then it's accelerating at 4 meters per second squared. It's important to note that you would have to split this problem into two, and you can't just sum up those averages and use these equations. The next key point is units are crucial because when we're dealing with 1D kinematics, these equations all have base units. So we have to remember our base unit for time is going to be seconds. Our base unit for displacement is going to be meters. For velocity, it's going to be meters per second. And for acceleration, make sure these are all vectors. And for acceleration, it's going to be meters per second squared. And finally, our 3.6 conversion factor. So I just like to tell people this really quickly because often in kinematics, you're going to be converting from kilometers per hour to meters per second, which it comes up quite frequently. And you just multiply or divide by 3.6 to get to the desired one. So kilometers to meters or meters to kilometers, you would divide or multiply by 3.6 accordingly. And that would save you a lot of time instead of doing all the conversion factors of hours and kilometers and etc. So let's get into the actual equations we're going to be using. These are known as the big five equations. So notice here that these are the equations and each one is missing a variable. So what does that tell us? That tells us that we have a total of 5 variables in the kinematics problems that we can solve. We are gonna have 4 of them present in each equation we decide to choose. So that means to solve any kinematic problem, we only need 3 variables and 1 unknown. So for example, if we have the initial velocity, final velocity, and time, and we're looking for displacement, we would use this one because we don't have the average acceleration, but we have v1, v2, and time, and we're solving for d. So we would use this equation. That's pretty straightforward, and I also added a couple extra equations down here that I think are important to note. This is just the constant velocity problem, where velocity is equal to displacement over time. This is used when there is no acceleration. We have the velocity average, which is just finding the change in displacement over the change in time, and the average acceleration, which is finding the average velocity over, finding the change in velocity over the change in time. So the best way to actually understand these is using these equations to solve problems. So let's go ahead and solve a first practice problem. Codex, a famous rapper, needs to be at his concert at 5 p.m., which is 5 kilometers away. If he decides to leave at 4:50 p.m. and he starts driving from rest at an acceleration of 0.1 meters per second squared in his broken car, will he make it? So let's highlight some key information we have. We know that his concert is going to be at 5 p.m., so that's going to be important. We know the distance is going to be away, which is 5 kilometers. We know that he's leaving at 4:50 p.m. We know that he's going to start driving from rest. We'll get into why that's important. We know his acceleration is 0.1 meters per second squared. And it's asking if he will make it or not. So let's digest everything we have here. So we know that he's going to start at he's going to need to get there at 5 p.m. and he starts at 4:50 p.m. Not equals, 4:50 p.m. So that means he's going to have a 10-minute range in where he can get to his destination. We know that he's starting from rest. So what does that mean? Starting from rest is always important to note because that means their initial velocity is equal to 0 meters per second. We know that his acceleration is going to be 0.1 meters per second squared. So we can write that acceleration is equal to 0.1 meters per second squared. And finally, we know that the distance is 5 kilometers away. So that is a distance of 5 kilometers away. And it's asking, will he make it? Okay, so before we go into actually solving this problem, let's convert all of our units into our base units that we have described right here. So we know that he has a 10-minute span to get there. So 10 minutes in seconds would just be 10 times 60. So we know that he has 600 seconds to get there. We know that this is already in meters per second. Acceleration is in meters per second squared. And displacement is in kilometers. So to get from kilometers to meters, we multiply by 1,000. So we know that it is a distance of 5,000 meters where he has to travel. So now we have our 4 variables. But this is weird because we have 4 variables. These equations only include 4 variables. So what exactly are we solving for here? Now we take note of the question. It's asking, will he make it? So that means in this time traveled with these conditions, will his time be less than 600 seconds? So there we go. So now we need an equation that has V1, acceleration, displacement, and time. So the one we don't have is final velocity. Let's look at which equation that's going to be. The one without final velocity is right here. So let's go ahead and use this equation. So the equation we're going to be using is the change in displacement is going to equal to the initial velocity times the change in time plus 1/2 the acceleration times the change in time squared. It's important to set up a coordinate system here. We know that we're going to set right as positive and left as negative. Up and down doesn't matter because we're dealing in 1D right now. So we just know that right is positive. And if we're drawing a sketch right here, we can assume that his car will be traveling this way, which is in positive, to get to his concert. So now let's go ahead and utilize our equations. So we know that our displacement is 5,000 meters. So we'll write 5,000 meters. We know that its initial velocity is 0. So it's 0 times t, which is just going to go to 0 because 0 times anything is 0. Then we're going to have plus 1/2 of its acceleration, which is 0.1 meters per second squared, times its change in time, which we don't know yet, which is what we're solving for, so t squared. So what can we do with this equation? Let's multiply both sides by 2. So we get rid of that. And then divide both sides by 0.1 meters per second squared. So we can get rid of that. 0.1 meters per second squared. Okay, and now we can go ahead and solve this. So 2 times 5,000 is going to be 10,000 divided by 0.1 is going to be 100,000. So we know that it's 100,000 is going to equal to t squared. We're going to take the square root of both sides, and then we get our time to be approximately 316.2 seconds. So what have we deemed here? We have now realized that it's going to take Codex to get to his concert 316 seconds. And we know that he has a total of 600 seconds to get there. And so we can write, since 316.2 is less than 600, he will indeed make his concert. So now let's move on to our next practice problem. I want you to go ahead and pause the video and try to try to solve this one yourself, because this one is a little bit more challenging, but very doable. Okay, so let's try to start it. So let's read the problem. Codex comes up with a new plan. He decides to borrow his friend Wesley's car, which, starting from rest, can accelerate at 1.5 meters per second squared until a speed of 40 meters per second is reached. He then no longer accelerates. If the concert is 5 kilometers away and he leaves 5 minutes before the start, will he make it? Okay, so there's a couple conditions here. Let's highlight it and then highlight key information that we're going to need. So he decides to borrow his friend Wesley's car, which, again, starting from rest. So as we know, this tells us our initial velocity is 0. We know that his acceleration is going to be 1.5 meters per second squared. And he goes until a speed of 40 meters per second is reached, and then he no longer accelerates. We know that the concert is still 5 kilometers away, and he leaves 5 minutes before the start, and it's asking again, will he make it? Okay, so let's draw out a sketch to visualize what we're dealing with here. And first, let's just set up our coordinate system. We're going to set right as positive and left as negative because he's only driving in one direction. So we have the concert right here, and this is his car. So we know that Codex is going to be starting from rest. So he's going to have an initial velocity of 0 meters per second, and he's going to accelerate with an acceleration of 1.5 meters per second squared until some point, let's just call it point X here, until a velocity of 40 meters per second is reached. And then he no longer accelerates. So that means this distance here, he's going to have an acceleration of 0 meters per second squared and a velocity of 40 meters per second. And we know that the total distance from the concert is still going to be 5 kilometers, which we deemed is 5,000 meters away. And he leaves 5 minutes before the start. Will he make it? So what does 5 minutes before the start mean? We know that he's going to have a total time of 5 minutes to get there. 5 times 60 is 300. So we know he's going to have a time period of 360 seconds to get, or 300 seconds to get there. So now how are we going to approach this problem? The easiest way to approach such a problem is to break it up into 2 pieces. So first, let's solve this part. So we know that at that part, he's going to have an initial velocity of 0 meters per second. He's going to have an acceleration of 1.5 meters per second squared. And we know that he's going to travel until his final velocity is 40 meters per second. Okay. And now let's digest this part of the problem. So what is this part of the problem telling us? Since there is 0 acceleration, we can use our formula v equals d over t. So we actually only need 2 variables here. So we know that his velocity is going to be a constant 40 meters per second the entire trip. And we are now a little stuck because we don't know what time he has and we don't know what displacement he's going to go. So let's figure out this first part of the problem before we move on to the second. So what are we going to solve for here? We could either solve for time to see how much time it takes for him to travel from here to here, or we could solve for displacement and see how much distance he covers from here to here. So let's go ahead and solve for distance. You could pick either one, but we're just going to choose distance. So we have V1, V2, acceleration, and we need to find D. So our missing variable is going to be time. So let's see which formula we're going to use. The one without time is going to be right here. So that's V final squared equals to V initial squared plus 2AD. V final squared is equal to V initial squared plus 2AD. So let's plug in our values. We know he's going to have 40 meter per second squared. Final velocity, initial velocity, 0 squared plus 2 times his acceleration of 1.5 meter per second squared times his displacement. So we know that this is just going to go to 0. We can divide both sides by 2 times 1.5. So get rid of this and get rid of this. And doing so means displacement is going to equal to 40 squared divided by 2 times 1.5, which is going to give us a value of 533.3 meters. So what do we now know? We now understand that this car is going to travel 533.3 meters in this distance. So that means this distance remaining to the concert is going to be 5,000 minus 533.3, which is approximately 4,466 meters. So we now have our distance traveled, 4,466 meters, 4,466.66 meters. So now we can solve for time. let's go ahead and solve for the time it's going to take him to travel this distance. So we know that the velocity is going to equal to 40 meters per second. The distance is going to be 4,466.6 meters over t. We just multiply both sides by t and divide by 40, which is going to give us a time of 111 seconds. Okay, hold on a second. We now know that it's going to take him this long to travel this distance. And we know that this is the distance he's traveling. Something's not right here, right? Because we don't know what time it takes him to travel here. So now we can sub this back in with these variables to find the time it takes him to travel this amount. Right? So now let's go ahead and I'll explain this a little bit more because it might be a little confusing. So we know how much distance he's going to travel in each of these. We found that. We know how much time it's going to take him to travel this, but we don't know how much time it's going to take him to travel this distance. So if we find the time it's going to take him to travel this distance and then add it up to the time it's going to travel this distance, we can see if that's less than 300 or greater than 300. So let's go ahead and do that. So what variables do we have here? We have the distance he's going to travel. We have his initial velocity and his acceleration. We could use this one as well, but we only need 3 to solve for another variable. So we have our missing variable is going to be v2. So let's go ahead and find that equation. So again, it's going to be this one. So d is equal to v1t plus 1/2. So delta d is going to equal to v1t plus 1/2 at squared. So let's go ahead and sub in our values. We know that the displacement is 500. Our v1 is going to be 0, so times t, that's just going to bring it to 0, plus 1/2 of the acceleration t squared. So multiply both sides by 2, divide by 1.5. So cross that out. We know that's equal to t squared, so that's going to give us 2 times 533.3 divided by 1.5. That's going to give us t is equal to 700, or t squared is going to give us 700.11. We square both sides. So we get the time it's going to take is 26.67 seconds. So now we know the time it's going to take Codex to travel from here to here and from here to here. So let's add them up. So we're going to add this time up with this time, and that's going to give us a total of 137.67 seconds. Okay, so now what have we found? We have found that in this total distance, it's going to take Codex 137.67 seconds to get there with these restrictions, and we know that he has 300 seconds to get there. And since 137.67 is less than 300, we now know that he will indeed make it to the concert on time. So that is the quick gist of 1D kinematics. Please let me know if there are any other problems you want me to solve, or if there are any things you want me to go over again. And thank you so much. Make sure you like and subscribe, and I will be going over more physics problems soon.